So today we're going to be looking at the arc length. The arc length is some fraction of the circumference of a circle. So for a circle, if we have a radius of r and a central angle theta, which is measured in radians, so make sure it's measured in radians, and it intercepts an arc of length s, then we know that the arc length is s is equal to r times theta. Or if we want to solve for theta, it's theta is equal to s over r. Once again, r is the radius of the circle that's given, s is the arc length, and theta is the central angle. And make sure that it's measured in radians. So if we look at a picture here, so we're going to have our central angle theta, our radius r, and then this part right here, this is going to be the arc length. So it's some part of the circumference of the circle. So let's look at an example. The first one, what we want to do is we want to find the central angle of a circle with a radius of 1.7 feet that intercepts an arc length of 2.5 feet. So we're going to start with the formula. We know that our arc length is equal to our radius times theta, or our central angle. What we know is that our arc length is 2.5 feet, so let's substitute that in. Okay, and we're given that the radius is 1.7 feet. So our job is to find the measure of the central angle. So all we need to do is we need to solve for theta. So we're going to divide by 1.7 on both sides. So when we divide 2.5 by 1.7, what we're going to get is that theta is going to be equal to 1.47. And this measure right here is in radians. So this is in radians. Let's look at the next example. What we want to do is we want to find the radius of the circle shown. We know that the central angle is 47 degrees and the arc length is 5.6 centimeters. So we're going to start with the same equation. We have that the arc length is equal to the radius times our central angle. The key thing here is we notice that the central angle is in degrees. So the first thing that we need to do is we need to convert it. So we're going to convert 47 degrees into radians. So we're going to do 47 degrees times pi over 180. And then when we reduce this, we multiply it out, we get 0.2611, and then this would be in radians. So now what we could do is we can find what our radius is since we have the central angle in radians. So we know that the arc length, it's 5.6 centimeters, and our central angle is 0.2611 radians. So let's write that in. And we're looking for the radius, so we're solving for r. So we're going to divide both sides by 2.611. When we divide both sides by our central angle, we find that the radius is going to be 21.45, and we need to know what the unit is, so it's going to be in centimeters. Let's look at the last example. So what we want to do is we want to find the distance in miles between San Francisco and Seattle. And we know that San Francisco has a latitude of 37 degrees, 46 minutes, and 39 seconds. And Seattle has a latitude of 47 degrees, 36 minutes, and 32 seconds. And what we know is that the Earth's radius is about 4,000 miles. So let's draw a picture to see how this would look. So here we have the Earth, and we know that Seattle is above San Francisco, so there's Seattle, and then there's San Francisco. So we're going to do an angle, because remember what we need to do is we need to find kind of the arc length, so the distance between them. So we need a central angle, so right here. So the first thing that we want to do is let's convert our minutes and seconds into a decimal. So we'll do it both for San Francisco and Seattle. So we're going to take 37 degrees, 46 minutes, and 39 seconds. And we want to convert it to a decimal. And remember that this is still in degrees. So go ahead, you want to put it into your calculator. And your calculator will give you that it's 37.7775. And we want to do the same thing for Seattle's latitude. So 47 degrees, 36 minutes, and 32 seconds. If we go ahead and convert it, that's going to be 47 degrees, 0.608 repeating. So now we know what our degrees are without our minutes and seconds. So we need to subtract to see kind of what the difference is between them to find that central angle. So let's go ahead and subtract them. So 47.6088 minus 37.7775. Okay. And then I'm going to do some rounding. When we subtract, we get, it'll be 9.83 degrees. So I subtracted them and I rounded it to the nearest tenth. But the key thing here is our angle is still in degrees, so we still need to convert it into radians to get the arc length. So 9.83 times pi over 180. And then when we convert that into radians, we get 0.172 radians. So now we have all the information that we need. We have the central angle, it's in radians, and we have that the radius of the Earth is 4,000 miles. So now we can go ahead and find what the arc length is, so the distance between the two cities. Remember, our arc length is equal to our radius times our central angle. So we have our radius is 4,000. And their central angle is 0.172 radians. If we multiply them together, we get that our arc length is about 688, and then we need to have a label, so miles. So the distance between San Francisco and Seattle is about 688 miles.